Why, hello there. Thank you so much for joining me for this video. In this video, we will cover questions number 21 through 24 of the January 2023 Algebra 1 Regents. We're coming up on the end of the multiple choice section, so make sure that you go ahead and watch all the videos in sequence so that you can get prepared for your upcoming Regents exam. Let's get started. For 21, it says, which representation yields the same outcome as the sequence defined recursively below? Remember, a recursive function will always start off with the initial value. So for here, we have the initial value, a sub 1 equals 3, and every subsequent value is going to be based on the preceding number. So a sub n is going to be equal to -4 plus a sub n minus 1. When we take a look at our answer choices, choice 1 and 2 represents what the numbers will look like in sequence, and choice 3 and 4 represents an explicit function. Let's write out our sequence to see how the numbers are behaving. A sub 1 equals 3. So a sub 2 is going to be -4 plus the number that came right before, which was 3. So we have -1 for a sub 2. A sub 3 is going to be -4 plus the number that came right before, which if you can see right here was -1. So we have -5 for a sub 3. A sub 4 is -4 plus -5, which is -9. Let's just do one more. A sub 5 equals -4 plus -9, which is -13. So we can see that our sequence starts off with the number 3, then goes to -1, then -5, -9, and -13. Let's see if our answer choices have this as a potential. This sequence mirrors the information in answer choice 2. So that is our correct answer. If we wanted to express this as an explicit function, we would need to determine how the numbers are changing. So to go from 3 to -1, you should see that the numbers are going down by 4. Then -1 to -5, again, down by 4. Then -5 to -9, down by another 4. So we can see that there is a constant rate of change of -4. Think back to linear functions, that would be our slope. So in our explicit function, I would be looking for something like -4n, and our initial value would actually be a sub 0. So think about it, if we were moving backwards, right? To go forward, we had to subtract 4. To go backwards, we're going to add 4. So our initial value will start off at 7. That is going to be our y-intercept. Let's test it out. A sub 1 would be -4 times 1 plus 7. So take a look, -4 plus 7 is 3. That is accurate. A sub 2 would be -4 times 2 plus 7, or -8 plus 7. That's -1. A sub 3 would be -4 times 3, or -12 plus 7. That would give us -5. So it looks like our explicit function is working for us. But if you notice, that is not equivalent to answer choice 3 or 4. So we know for certain that answer choice 2 is the correct answer. Let's move on to the next problem. For question 22, there is an algebraic approach and there is a calculator approach. So I will certainly show you both in this solution. If the zeros of the function g of x are -3, 0, and 4, which function could represent g of x? Oftentimes, we've shown you that the roots of the function can easily be used to determine the factors of the function. Since one of the roots is -3, we know that the first factor of the function is going to be x plus 3. Since the second root is 0, we'll have x plus or minus 0, but we already know that x plus or minus 0 is just x. So that's another factor. And finally, we can have x minus 4 as another factor. Let's keep in mind the language that was used here in the problem. It explicitly states which function could represent. So this doesn't account for any coefficients. Let's say there was a 2 here or a 4 here. that's right outside the function, that would still be a representation of a function with the same zeros. So this is not the exact equivalent version of a function with those zeros, but it is a potential answer. And that's all they're looking for in this problem. So when we look at our answer choices, we're looking for one that has x plus 3 as a factor. So I see that in answer choice 1, but it also needs to have x as a factor. So I'm going to eliminate answer choice 1 and 2. I notice that answer choice 3 has x as a factor, x plus 3 as a factor, and x minus 4 as a factor. So that is our correct answer. Answer choice 4 is incorrect because, unfortunately, they switched the signs. Let's take a look at our table of values. To find zeros in a table of values, we are looking for the following points: -3, 0, 0, 0, and 4, 0. Let's take a look to see if our answer is correct. Since we already have a potential answer choice, so I will go ahead and test out answer choice 3 to see if it's the correct answer. We have x, open parentheses, x plus 3, close parentheses, then another open parentheses, and we have x minus 4. Now we're going to hit second graph to look at the table of values. And we said before that we're looking for the points -3, 0. This looks good. 0, 0. This looks good. And 4, 0. That is what it means for these numbers to represent the zeros of the function. The other piece of information that I want to remind you is zeros is also known as roots, solutions, and x-intercepts. Those are the 4 ways that this same concept can be discussed. Make sure you have those 4 vocabulary words in your arsenal so that you can master problems that come up of this nature. Let's head over to question 23. For question 23, it says that Morgan read that a snail moves about 72 feet per day. He performed the calculation 72 feet over 1 day times 1 day over 24 hours times 1 hour over 60 minutes times 12 inches over 1 foot. To convert this rate to different units, what are the units for the converted rate? And we have different outcomes here in our answer choices. I love this type of problem. I actually learned it when I took my science classes at a high-performing high school in New York City, and this was such a good way to do your conversion. So I just want to break down this concept because I think it's helpful in math, but it's also going to be helpful in your science classes. So if you notice here, it started off as 72 feet per day. So your goal is to write the conversions in a fraction form. You have to also remember that any number or term in the denominator can be canceled out with any number or term in the numerator. Remember that rule. So if we have 1 day in the denominator, I'm looking for days to be represented in the numerator. The second piece of information I'm looking for is whatever the equivalent is for 1 day in terms of hours needs to be represented in its denominator. So this looks good because we know that 1 day is 24 hours. The next thing I'll be looking for is if hours are in the denominator, then I need to see hours right here in the numerator. So let's start canceling out. Days is going to cancel out with days. Hours will cancel out with hours. And we're literally just canceling out the words. That's it. We still need to acknowledge the numbers, and we'll take care of that in a second. But we want to make sure that the actual units are canceling out. We also want to make sure that the right conversions are represented. So 1 day equals 24 hours, and 1 hour does equal 60 minutes. Now notice minutes are here in the denominator, and we don't see any minutes in the numerator that's going to cancel out. So we have to leave that one alone. We also see here that 12 inches is equal to 1 foot, which we know is absolutely accurate. The last piece of information that we can apply here is that feet or foot is right here in the denominator, and that's going to cancel out with feet over here in the numerator. So we successfully canceled out all of the units except inches here in the numerator and minutes in the denominator. So guess what? That is going to be your final answer. The units for the converted rate is going to be inches per minute. Guys, do you see how easy that was? We didn't even have to do any computation. All they wanted you to notice is what words are canceling out and what words are left behind. So we have inches per minute. I just want to do a quick extension to let you know what you would do if you did have to calculate the final answer. Now that we've canceled out all the words that no longer belong, we're going to go ahead and pay attention to the numbers. So we would have 72 times 1 times 1 times 12. And we're going to divide that by 1 times 24 times 60 times 1. And we would find our final answers. Just to refresh your memory, this part of the problem is not necessary because the question was only asking for the final units for the converted rate. But I just want to make sure that you understand how you would solve this problem in the event that you were asked for the full, complete answer. We extracted all of the numbers, incorporated our multiplication operation, and now I love to cancel out. So I'm going to start canceling out what we no longer need. So 12 divided by 12 is 1, and 60 divided by 12 is 5. We also know that 24 divided by 24 is 1, and 72 divided by 24 is 3. So now we can simplify our final answer. So we have 3 times 1 times 1 times 1. So we have 3 in our numerator, and we have 1 times 1 times 5 times 1, or 5 in the denominator. Our final answer would be 3/5 inches per minute. We can also convert this into a decimal. So you might also see the answer choice in the future of 0.6 inches per minute. Hopefully this was pretty straightforward. It's easy points, but sometimes students do struggle with this. So just start out by canceling out the units that don't belong. Let's head on over to our final problem for the multiple choice section of the January 2023 Regents. For question 24, we have a real world system of inequalities. Let's annotate the word problem together. During summer vacation, Ben decides to sell hot dogs and pretzels. On a food cart in Manhattan, it costs Ben 50 cents for each hot dog and 40 cents for each pretzel. He has only $100 to spend each day on hot dogs and pretzels. He wants to sell at least 200 items each day. If H is the number of hot dogs and P is the number of pretzels, which inequality would be part of a system of inequalities used to determine the total number of hot dogs and pretzels Ben can sell? Let's set up the system. I prefer to start off systems by focusing on the totals. The first total we have is $100, and the second total we have is $200. So let's interpret what they mean. If Ben has only $100 to spend each day on hot dogs and pretzels, that typically means he has to spend less than or equal to $100. Because $100 has to do with money, we're going to incorporate the cost of the hot dogs and the cost of the pretzels. So that would be 0.50H plus 0.40P must be less than or equal to $100. Then we have the quantity inequality. That's 200. He must sell at least 200 items. Anytime you see the term at least, that means greater than or equal to 200. So when you put the total number of hot dogs and pretzels together, that total must exceed or be equal to 200. Let's look at our answer choices. Notice none of the answer choices have the number 100. So they don't want us to consider the first inequality here. We should be focusing on the second inequality. We're looking for H plus P is greater than or equal to 200, and that is answer choice 2. For this type of problem, you can go ahead and just set up the system and then compare your answer to what is available to you. This question completes the multiple choice section of the January 2023 Regents. If you learned something in this video, please go ahead and like, comment, share, and subscribe. And I'm excited to create more video content to support you on your journey to excelling on the Algebra 1 Math Regents. See you in the next video.